helpmegraduate.com series of videos regarding math and calculus. Now we're going to be talking about something that is very difficult for a lot of people that take calculus or math classes in first year of college, freshman year of college, sometimes senior year in high school, depending on where are you studying. It's called the chain rule, and it's the rule for to find the derivative of a composition of functions. Now, it sounds a little bit hard, and indeed it is, like for the first 2 or 3 weeks that you start tackling. Once you get the grip of it, you shouldn't have any problem, but of course, the main goal is exactly that, to get the grip of the rule. So, as you may have heard, I mentioned the phrase composition of functions, and that's pretty much the key and the tricky thing about the chain rule. What is a composition of functions? Well, I have a past video regarding that topic, but I'm going to reinforce that point of view in this little video about chain rule. Composition of functions, as you may have remembered or defined in the past class, is an evaluation of one function in another function. Okay, most trigonometric, exponential, and logarithmic functions are going to feature a composition of functions. Now, why is that happening? Well, because you have a trigonometric function doing something else, or an exponential function doing something else to the argument. And we're going to get to that in a few examples, because the first thing that you have to do before understanding the chain rule and the rule of finding the derivative of a composition of functions is understand the composition of functions. Once you're past that, you'll be able to do the chain rule in no time. So the first example I'm going to use is, say, something like sine x squared. Alright? Like I said, and take a big note of this little, mark it, this little thing I'm writing right here. Most trigonometric, exponential, and logarithmic functions are going to feature a composition of functions. Okay? Now, we have here sine x squared. Is this a composite function, or is it a plain just natural function? Well, if you answered composition, the answer is correct. There's two functions happening here. One is evaluating the other one. Where are they? Well, this is the first one, sine. Okay? And the second one, the smaller, is this one. Think about it this way. What is the plain regular function that you know trigonometric regarding sine? Well, it's sine x, right? Sine x equals y, or equals fx. Okay? This is a plain natural function. Nothing is happening to the x. Nothing is happening to the x apart from I'm just taking the sign of it. It's the only operation I'm doing to the variable. But right here, there's two things that are happening to the variable. First, I'm squaring it. Then, I'm taking the sin of it. Okay? That's a composition of functions. I'm taking a variable, I'm evaluating it, and then I'm doing a second major evaluation to that result. Okay? So, let's make another example. Say we have a logarithmic. For instance, natural logarithmic of 5x. Is this a composition of functions? Yes, there's two functions happening right here. The first one, the major one, is the logarithmic. The second one is 5x. So if I have a variable x, here's what I'm doing to it. First of all, I'm multiplying it by 5, and then I'm doing the logarithm of it. See? It's one little argument evaluated, and then there's a major argument. Okay? So you have heard me say the words argument and then major. That's pretty much the key of composition of functions. You have to find which is the first step, then the next one, which is the major one. Okay? Because both things don't happen at the same time. You see? If I go into the first example, I don't square the variable and do the sign of it at the same time, right? I just don't do that. First I square it, and then is when I do the sin of it. Okay? Same for here. First I multiply x times 5, then I do the logarithm of it. Both things don't happen at the same time. There's always one first. Okay? And the one that happened last is the major one. Okay? That's why I'm being consistent with the blue as the major argument. The red is the smallest one, or the first step I'm doing, and then the blue is the major, the final one. Okay? Let's do another example. Say we have, let's use the upper part of the board. Let's say we have something like cos sin x cubed. Is this a composition of functions? Well, let's take a look. Again, think about it as a mathematic, okay? Think about what's happening in the problem and just talk to the problem. Ask the problem what's going on, and you will get the answer. What is happening with this function? Well, let's do the y thing. Well, I have a variable. It's called x, right? Doesn't matter what number it is. It's just x. What am I doing to x? Well, first of all, I'm taking the cube of it, okay? Then I'm doing the sin of it. And then I'm doing the cosine of it. So I'm doing 3 things to a variable. This is a composition of 3 functions. X cubed, sin, and then cosine. Okay? 3 different things. So here we have 1, 2, 3. Which one is the first thing that I do? I take the cube of it. Then which is the second one? I do the sin of it. And then which is the last one? The cosine of it. Okay? So that thing is very important for you to determine, right? Which are the steps that are applying to the variable. Once I'm able to do that, I'll be able to tackle the chain rule. Okay? Now in the next video, we're going to start doing some exercises of composition of functions, derivatives, using the chain rule.